Hello and welcome back to another Duncan Codes. My name's Duncan and today we're going to continue with the object-orientated programming course from the University of Helsinki. So let's get cracking. Last time we completed a couple of exercises and today we're going to get started with the whistle program or challenge. And what we've got to do is create a class named whistle, add the variable private string sound to the class. After that, create a constructor, public whistle, which is passed one variable, which is string whistle sound, and then that is used to create a new whistle that's given a sound. So before we begin, we'll quickly update our GitHub repositories. So we'll do git add full stop, and that will update our repository with any changed exercises. We'll add git m and then add in there completed challenge 4 or whichever message you wish to upload, and then we'll do git push u, and then we'll do git push u commit. From there, what we're going to do is go to our source packages, and then we're going to open up our main package, which is the default package in this instance, and let's have a little look. So we've got our main class. We're going to need to create a Java class called whistle, so let's quickly do that. And there we go. So let's have a quick look back here. So we need to add the variable private string sound. So remember, any private variable contained within a class is going to be encapsulated. So we're going to create that. So let's just pop that in. So we've got private string sound, and now we need to create the constructor. And remember, a constructor is just a posh method, and the only real difference in the look of them is that the constructor will have a capital first letter, whereas normally it's camel case. We are passing one variable, or one parameter, sorry, which is going to be string whistle sound, and then we're going to write that this sound, which is on line 12 here, is going to be equal to the value we pass it when we create an instance of this class. Okay, so let's go back to our main class now, and here what we can do is type in the code. They've already typed it in, wonderful. So if we just select that and press Control and / on our keyboard, that will uncomment it for us, and we've got a little error here, so let's go back and have a look at that. So it's asking us to use a method called sound. Oh, okay, so we need to add in another method by the looks of it. Add a variable private string to the class. After that, create a constructor, whistle sound, which is used to create a new whistle that's given a sound. So duck.whistle.sound. We don't actually have. So this on the end here of duck whistle and rooster whistle, etc., is a method, but they haven't actually told us to create the method .sound. So let's just head back to whistle. We can't change the constructor from public whistle to public sound because the constructor needs to have the same name as the class. So what we're going to do then is create another method called public sound. And then in there, what are we going to put in there? So what we can actually do in there is pass it the string whistle, and then, whistle sound, and then we can get it to print out we can get it to print out the whistle sound, like so. So let's have a little look at that. Methods. Oh, right, so here between our parentheses we haven't passed a whistle sound, so we can't actually use that. So what we need to do is go back and remove whistle sound from here and the string bit, and then what we can do is change the output from whistle sound. So we'll get rid of this string bit. We'll change the output from whistle sound to sound, which is our private variable that we've created on line 12, and then that should do the job. So if we just head back to our main, you can see that we've got the instantiations of the objects. When the object is created, it is passed a sound, and that sound will be passed to the constructor, and then if we look at our constructor, the whistle sound is going to be saved in the private variable, and then when we call the duckwhistle.sound method or the roosterwhistle.sound method, it's going to take the details from the private variable and print them out. And because we've created the objects on lines 8 and 9, this variable will have a value, which is the variable that we are, the value that we are passing it on those 2 lines. Okay, so let's give that a test. That looks good, excellent. That one was a bit tricky in the sense that it didn't actually tell us to create the sound method. Let's close that one down. Oops, didn't mean clean, I meant close. Where's close? There it is. And then let's go back to our GitHub. So we do git add full stop to add all of our changes that we've made. And we're going to type git commit -m, and then we're going to put our commit message in there, which will be completed part 4, challenge 5, press enter, and then we can do the git push u origin and master and get that one all sent off. There we go. So let's have a look at what we're doing now. So it's the door challenge. So let's get our main open and have a quick look and see what we've got. So we've got some pre-completed code there. Let's have a look at the challenge. So we need to create a class named door. The door does not have any variables. Create for it a constructor with no parameters, or use the default constructor. After that, create a public void called knock method for the door that prints out the message who's there when called. So let's go ahead and create that door class, and we can put a blank constructor in if we need to, if we want, or use the default constructor. So there we go. Use our system out, get that typed in. Okay, let's uncomment that code. So what I've done is I've created the constructor, and I've put the system out in the constructor, not the method they asked us to create. So we need to create a new method, which is going to be the public void knock. So let's get that sorted. I'll cut that out of there, and we can put that in the method we're going to create now. So public void knock, and then in there we can put system out who's there with the question mark on the end. So let's give that a little run locally. Excellent, that was quite a nice, quick and easy one, wasn't it? So that's passed. Let's get that sent off and see what we get back. Excellent, so that one's all done. Let's have a little look and see what we've got next. So we've got a challenge called the project challenge. Let's just get this door closed, and then we'll have a look at this new challenge here. So this is challenge 7, and it says create a class product that represents a store product. The product should have a price, which is going to be represented as a double, and a quantity, which is going to be represented as an int, and a name of type string. The class should have the constructor, public product, string initial, comma double, initial price, comma int, initial quantity, and then a method which is public void print product that prints product information in the following format. And then we've got banana, comma price, 1.1, comma 13 pieces. Okay, let's get cracking with that then. So the first thing we're going to do is create our new class. So we're going to call that product, and then inside there we're going to create our private variables. So remember, because they're private, they're encapsulated. So we're going to have private string name, private double price, and private quantity. We've got public product, and then inside there we're going to pass string initial name, and then double initial price, and then finally the last thing is int initial what was it? Initial what? Initial quantity. So let's get that in. There we go. And then inside here we're going to do this string, or this dot name, sorry, which is referring to the variable on line 12, is equal to initial name, which is our first variable passed as a parameter. Then we've got this dot price, which is the variable on line 13, which is equal to our second passed parameter, which is double initial price. And then this dot quantity, which is equal to initial quantity, sorry. There. Excellent. So we've got those. So it said we need to create another method as well. So we need to create a method called print product. So let's get that printed there. And it needs to print product information in the following format. So let's do a system out. And then the first thing that we're going to do is the name, and then we're going to use concatenation, and we can build a string. So after that we've got a comma, price, then space plus price, and then comma, space plus initial quantity, and then we need to, quantity, and then on the end there we need to put on the pieces like so. Let's have a little look at that and see what we get back. Oh, need to uncomment the code first. There we go. Right, let's give that a run. That looks good. So here we've got the pieces as a double. Let's just see what we get back anyway, because a double can be passed to an integer, so it may well work, but let's just have a little look anyway. Excellent, that's passed. So let's give that an OK. Let's give our page a little refresh and see what we've got next. So we've got changing an instance variable's value in a method. Let's add a method to the previously created person class that increments the age of a person by a year. So we've got public class person, we've got our private strings in there. Let's see, so if I just open the one that we created, there's only one new method on there, which is the one at the bottom, which is grow older. So we can type in that into our class, and then all they're doing is adding 1 to the age value. So if you think back to what we've looked at so far, there are a few different ways that we can add 1. So they've used this.age is equal to this.age plus 1. So that's one way that we can do it. There are other ways as well, which, as long as they give the correct results, aren't a problem if you want to use those ways. So let's just head back here. The method is written inside the person class, just as the print person method was. The method increments the value of the instance variable age by 1. The class diagram also gets updated. So you can see at the bottom on our class diagram here that we've got a new method with a plus next to it, which means it's public, and that's the grow older method. So let's call the method and see what happens. So let's head back to our main here, and let's do Duncan.growOlder. Remember our parentheses on the end and our semicolon. And then we can use Control, Shift and Up to repeat that quite a few times. And then see what's what. Oh, so here it hasn't actually worked, but that's because I haven't put a printout. So you can see here on line 26 it's printing out our age as 0, which is correct, but then we use the grow older method a few times, so we actually need to reprint the information out. So you can see here that now it's correct, it's equaling 4, so that's good. Okay, so here's their example. So they've got Ada as 0, and then they call the method a couple of times. Then Ada's age increases to 2 years. So back to the write-up. So that is to say that when the two objects are born, they are both 0 years old. So this age is equal to 0, is executed in the constructor. The Ada object's grow older method is called twice, as the printout demonstrates the age of Ada is 2 after growing older. Calling the method on an object corresponding to Ada has no impact on the age of the other person, since each object is instantiated from a class has its own instance variables. The method can also contain conditional statements and loops. The grow older method below limits aging to 30 years. Wouldn't that be nice? So here they've updated it. They've updated their grow older method just to say, provided the age is less than 30, you can add 1, but if it's above that, you can't. Right, so we have now got a decreasing counter challenge, which is a 3-parter, so that's going to be quite good. I like the way that they do these multi-challenges. Actually, let's just quickly update our GitHub. So we've got git add full stop, which will add all of our previously changed code in, or all of our previous changes. Git commit, and then git push u origin master. So the exercise consists of multiple parts. Each part corresponds to one exercise. The exercise template comes with a partially executed class called decreasing counter that we've got here. So we've got a constructor here, which is on line 6 to 8 inclusive. We've got one private variable, which is value. We've got public void print value, which prints it out, and then we've got a decrement value, or decrement. So we need to write the method there, and the aim is to decrease the value of the counter by 1. So that's going to be very, very similar to what we looked at for the person code. The only difference being is that we're going to be minusing 1 instead of adding 1. So let's just have a quick look in our main and see what we've got. So we've got counter.print value and then 2 decrements, or decrements. So let's add in our code that we need. Let's get rid of this comments. And then what we can do is say this.age is equal to, sorry, it's not age, is it? It's value. This.value minus equals 1. So remember I was saying there's a few different ways that we can do it. So minus equals 1 is one of those ways. Let's give that a run locally and see what we get back. Okay, so we've got one pass. And if we look back at the code examples on the right hand side, you can see it says the program should have the following print output. So value 10, value 9 and value 8. So let's scroll down a little bit, just double check and see what the next challenge is. And then part 2 said the counter's value cannot be negative. So implement the decrement method in such a way that the counter's value never becomes negative. This means that if the value of the counter is 0, it cannot be decremented any further. Okay, so a conditional statement is useful here. So we're going to use some sort of logic or conditional statement to check the value of value, and provided it's within the parameters, we can minus 1. If it is equal to 0, then we cannot reduce the number anymore. So we can use a simple if statement. So we can say if this dot value, because we're referencing the private variable, is greater than 0, and we can wrap our this dot value minus equals 1 in the curly braces and then indent it. Let's give that a test and hopefully we've got some more positive results. Let's see, there we go. So that one's now worked. So we've got that one passed. Now we have got decreasing counter test has no method reset. Okay, that's fine. So that must be part 3. So here we've got resetting the counter value. Create the method public void reset for the counter that resets the value of the counter to 0. For example, public class main program counter.print value counter.reset counter.print value. So we've got these examples here that show how the counter is being reset. Initially its value is set to 100, then it's reset, then it's set to 0. Then we've got the decrement method being called. It mustn't be able to go below 0. That's being called, and then we've got another printout to confirm it can't go below 0. So let's head back to our NetBeans and create the public void reset method. We're going to get our curly braces in there as well, and then what we need to do is set the value to 0. So all we're going to do is this dot value is equal to 0. So let's have a look and see how we get on with that. Excellent, that's all passed locally, so let's get that sent off to the server. And let's see what we've got next. Right, so it's good practice obviously to keep our GitHub repository up to date. So let's open up our git bash, and remember we need to do git add.fullstop. We'll put a commit message in, which is git commit -m, and then completed part 4 challenge, what challenge was that? 8? And then we can do git push u origin and master. Let's head back, just make sure we got our point. Got those there, that's good. Have a bit of a quick check overall. We've got doing pretty well on the points. Hopefully everyone's around the same sort of area with 100% sort of way through. If you're not, let me know and I'll do what I can to help. Right, let's have a look at this det exercise. So create the class det that has double typed instance variables of balance and interest rate. The balance and interest rate are passed to the constructor as parameters. So we've got debt, double initial balance, double initial interest rate. Then in addition, create the methods public void print balance and public void wait 1 year in the class. The method print balance prints the current balance, and the wait 1 year method grows the debt amount. That is a horrible method. The debt is increased by multiplying the balance by the interest rate. Okay, well, let's get cracking. So the first thing we're going to do is create our debt class. Now we're going to add in the two instance variables, which are going to be private double balance and private double interest rate. Remember, these variables are encapsulated because they're private, so they can't be seen outside of this class. Now we're going to create our constructor. So we've got public debt, and it needs to take two variables, which are double initial balance and double initial interest rate. Okay, then we're going to open our curly braces. Now we're going to add in the code. So we're going to say this dot balance is equal to initial balance, and this dot interest rate is equal to initial interest rate. That's good. Now we need to add in the two additional methods. So the first one is public void print balance. So that's going to be public void print balance, and then let's see, do we need anything to, oops, I put square brackets, not curlies, there we go. And then we need to add our second method, which is public void wait 1 year. So the first thing we're going to do is our print balance method. So let's head back up to my line 22, and we're going to put a simple system out in there, and then in between the parentheses we're actually going to put balance, which is the variable on line 12. For the public void wait 1 year, if we have a look back at the Helsinki code here on the right hand side, you can see in the main they've written a new initializer, which is debt mortgage equals new debt, and then they're passing the value of the initial balance and the interest, which it makes sense because that's what we're expecting for our constructor. So we are going to get given that information, so we can say that this dot balance is going to be times equals the interest rate. So now if we uncomment the code from our main, we can start to test the code that we've written and see what sort of errors, if any, we get and what we can do to debug and fix them. So here we go. We've got a few bits of red here. Oh, that will be because I've uncommented the comments on line 5 as well, so let's get rid of that. So at first glance everything looks okay. So let's give it a run. Let's see what we get. So that looks pretty spot on. So let's give that a test locally, and then see what happens. Excellent, that is fantastic. So that was actually quite a nice straightforward one as well, with not too many methods and things going on. The methods that we did use were quite short and succinct. They weren't sort of bloated or overly difficult to understand, hopefully. So let's have a look at this next section. So returning a value from a method. A method can have a return value. The methods we've created in our objects haven't so far returned anything. This has been marked by typing the keyword void in the method definition. So here on this example we've got our class, and then inside there we've got public void knock. The keyword void means that the method does not return a value. If we want the method to return a value, we need to replace the void keyword with the type of variable to be returned. In the following example, the teacher class has a method grade that always returns an integer type, or int, in this case the value of 10. The value is always returned with the return command. So if you look at that example there and compare it to the one above, instead of saying public void grade, it says public int grade. So a integer will always return a number or a variable that links to a number. A string will always return strings, and so on. The method above returns an int type variable of value 10 when called. For the return to be used, it needs to be assigned to a variable. This happens the same way as a regular value assignment. i.e. by using an equal sign. So here we've got our public static void main. In there we've got a teacher, and then we're using the teacher object to access the grade method, and then we've got the system out print, the received grade is, and then plus the variable there. So that gives us the output of 10. The method's return value is assigned to a variable of type int value, just as any other int would be. The return value could also be used to form part of an expression as well. So just as we've looked at concatenation and building strings and building outputs before, we can do a similar sort of thing with return statements as well. So for this example here, you can see that we've got 3 teachers this time, first, second and third. First, second and third are the object names, and then you can see that the variable double average is made up of the first grade, the second grade and the third grade all added together and then divided by 3, and then that answer is printed out on the line below that, explaining that the grade average is 10. All the variables that we've encountered so far can also be returned by a method. To some, a method that returns nothing has the void modifier, so here we've got public void. Here we've got a public int and a string. What I'm actually going to do, let's drag that, let's move that to the right, and I'm going to open the person example again. So let's do that. Actually, I'm just going to quickly open that. So my main is called get example, which is a stupid name. Right, what I'm going to do is add some methods in. So when working with your main, you need to make sure that any new methods are added outside of the main. So this is the end of main, and then here we've got end of class. So our new methods will need to be in between those 2 points. But what I'm going to do is expand on the examples that they've put here. Oh, gone the wrong way. There we go. So public void, that's fine, I'll leave that one. But the public int, I'm going to method, let's show you how the return would work. Method that returns int. So it doesn't need to be dramatically any different. You can see that that is basically our sort of standard method that we've been using, perhaps with the addition of the keyword static. But that should look very good to you. There's nothing really wrong with it, yet we've got this error here. And the great thing about our IDEs are that if we declare a method as anything other than void, it will give us a reminder saying that there's a missing return statement. Okay, so we can click on that and it will add a return statement in, just a generic one that returns 0 or -1 or something like that, which really isn't especially useful. So let's just change this to addition, and then what we could say is int a and int b are going to be 2 parameters that are passed, and our return statement, instead of being 0, which isn't especially useful, we could return a plus b, and then that will do the maths for us and return the answer. So that's quite a good method in that it's efficient. Obviously there are different ways that we can do it. We don't have to do it that way. We could put a scanner in here, scanner to take user input, store input in 2 variables for variable 1 and variable 2 if you do an addition. We could say that the int answer, I'm not going to code the whole thing, but just say for example it's 4, instead of returning 4, which we could do, but it's static so it won't change, so it seems a bit, not really much point for this example, we can return answer. So there are lots of different ways that you can return values in programming. So the next one we've got is the public string method. So let's just quickly delete this one. And then we've got public, remember string has a capital S, so we've got public string, I'll just call it example. And then again, we can pass parameters if we need to, that's not a problem, or we can leave it without pass parameters and we can take user inputs. But again, because we've got a data type that isn't void, it's reminding us that we need to add this return statement. And you don't need to click on that icon every time if you want to add a return statement in, you can type it yourself. It doesn't need to be, it's not automated. And you can return any type of string. So the string could be null, it could be empty, it could be something between quotes. So the last example they've got there is double. So if I change this to double, Our return statement would be expecting some sort of double number. So you can type in a static number if you want, or it could be addition, multiplication, subtraction, any form of arithmetic that you want to perform on a double, as long as it returns a double or a link to a double. And by a link I mean a link to a variable. So that is quite cool, because when you're coding we don't want everything returned to the console down here. Sometimes we want to return to a graphical user interface, and I'm sure we'll look at that later on through the course. So let's continue with the person class and add a return age method that returns the person age. So if I head back to my person class over here, I'm going to get rid of that. Oh, I've already got a return age. That's fine. So let's continue with the person class and add a return age method that returns the person age. So here we've got the added method, so I've already got mine typed in. So it's very similar to what we've used before. It's a int method, so you can see that it's expecting a return of integer, and it's returning this.age. And remember, the age is referring to the one here on line 14. Okay, and we've got our updated class diagram again. So our class is called person. We've got two private variables, which are name and age, and they're instance variables. And then here we've got four public methods. The top one is the constructor, and it takes one parameter, which is the initial name. So you can see here we've got that there. We've got print person, which is a void return type. We've got grow older, which is also a void return type. And then we've got return age, which has an int return type. So if we follow again through with this example here, we should be able to get the age output of our people. So let's go back and have a look. So here we've got my details being printed, then we're growing older 4 times, and then we are printing out the details. So let's have a look and see what output we get there. There we go. So you can see here when the print age, or print person, sorry, was ran the first time on line 23, I was 0 years old. Then I grew older 4 times, and then the output returned, you can see the output returned that I'm aged 4 years, and then we've got the actual method returning as well. So if we have a quick look at print person here, you can see that we've built a bit of a string to be returned, which uses the name and the age as well. I think what I'm going to do is stop the video here. I know this one has been a bit of a long time coming, so I really appreciate your patience with this, but I've just realised that we've done 3 videos so far and we're only halfway through, which is brilliant because there is a lot to go through, but I am conscious that I don't want the videos to be too long for you guys. So I will stop here. As always, if there are any questions or queries that you have, this is quite a big concept to sort of understand, so if you're feeling a bit lost or confused, that's absolutely fine. It's natural, it's a big concept to learn. Please feel free to ask questions. I'm starting to get a bit more active on Reddit as well. I was thinking of perhaps starting up a group for the University of Helsinki, where we could discuss answers, and maybe you guys could start chatting with each other, because a really good way to learn programming is by discussing it with others, and you guys all being at a similar sort of stage, it will probably be really interesting for you to hear other people's implementations, understanding of the code, and it might give you that sort of context that you need for a principle to be understood fully. So let me know what your thoughts are on that. I have already started recording the next section, and I hope to have that ready within the next 10 days. And as always, good luck and happy coding.